how these very specific prebiotic interventions actually like change the entire microbial landscape,
Yeah.
Not just in the system itself, which is already complex, but then inside the shrimp too.
A whole new era of communication in the global aquaculture industry is coming. Now you have the brightest minds in aquaculture right in your pocket. And what's best? You can listen to all of them while driving to a farm, traveling, or running errands. It's never been this good, and it's never been this simple. Welcome to the Aquaculture Podcast Show, the first AI-based podcast in aquaculture, where you'll find cutting-edge insights in everything that's working in aquaculture, nutrition, health, and production.
All right, diving in today. We're going to dissect a U.S. aquaculture study, a recent one.
Okay.
And, there's obviously been a lot of buzz about how to optimize those biofloc systems. So this research, it really gets down to the nitty-gritty using prebiotics, to fine-tune the microbial communities.
Right.
Specifically for Pacific white shrimp, Penaeus vannamei.
Yeah, absolutely. And I think, what's really cool about this is it tackles this core challenge in biofloc technology, right?
Yeah.
Like, how do we actually get these microbial profiles to be, well, first of all, more predictable, and then, ultimately more beneficial, both for the water quality, right, that we're all trying to manage, and the shrimp themselves. You know? How do we actually improve their physiological state?
And it's not just looking at, prebiotics in general. They actually went deep and looked at specific types: fructoligosaccharides, galactoligosaccharides, inulin, and manano-oligosaccharides. Compared them against non-prebiotic carbohydrates, your sucrose and wheat starch.
Yeah.
They really got into like the bacterial communities in the water, in the shrimp gills, hepatopancreas, intestines, the whole 9 yards.
Exactly.
Yeah.
I mean, the fundamental question they were trying to figure out, and what we're going to kind of unpack together here, is how these very specific prebiotic interventions actually like change the entire microbial landscape,
Yeah.
Not just in the system itself, which is already complex, but then inside the shrimp too. There's a lot of really interesting nuances in this data.
Okay, so the setup, they had this controlled environment, and they brought in those 4 prebiotics we talked about, the FOS, GOS, inulin, MOS,
Right.
along with your sucrose and wheat starch as those controls. Ran it for 26 days. And what's interesting is they followed it through both those initial phases, right?
Yeah.
The algal-dominated one, and then when it shifts to that bacteria-dominated phase.
Yeah, that's actually a really smart move in the study design, because it lets them see how those prebiotics actually, influence the whole succession of the microbes as the biofloc system, matured. And that time element.
Yeah.
I mean, that's super critical, right?
Yeah.
Because if you're thinking about the long-term impacts of using these in a real-world commercial operation, you got to understand that dynamic, right?
No, for sure. Now, here's something that, when I first saw, I was like, okay. So they found no real difference in the overall shrimp growth across the different prebiotic treatments. Now, what's your take on that? Because I know a lot of people are probably thinking, well, if you're making the microbial environment better, the shrimp should grow faster, right?
Right, and that's kind of the common assumption, that if it's a healthier microbial environment, it's just going to translate directly to, boom, faster growth. But I think what this might be hinting at is that maybe that connection isn't so straightforward, at least not in that initial, short term. But what is interesting, and maybe where things start to get really cool, is that they did see variations in the actual composition of the shrimp, like their nutritional makeup. Specifically, the MOS treatment that led to significantly higher muscle lipid content compared to the GOS group.
So you're saying, for the folks out there who are, really focused on feed formulation, maybe even processing,
Right.
that we might be able to actually tweak the nutritional profile, like in this case, get more lipids into that muscle just by using specific prebiotics.
Exactly.
Even if we're not necessarily speeding up the growth.
Exactly.
That kind of changes how we think about the final product, right?
It absolutely does. I mean, it opens up possibilities for tailoring the shrimp to specific nutritional needs or demands in the market. Now, let's kind of move from the shrimp itself to that biofloc environment for a second. There was a really interesting finding there about the actual concentration of the biofloc particles.
Oh, yeah. The wheat starch group, they had way lower biofloc concentrations than all the ones getting those prebiotics. I mean, if you're actually managing these systems, that difference in the biomass, that could really change things up, right?
Because remember, biofloc isn't just about cleaning up the water. it actually provides a lot of the nutrition for the shrimp.
Yeah.
And it helps keep the whole system stable.
Yeah.
So the fact that that wheat starch, which is not a prebiotic carbohydrate, ended up with lower biomass, it kind of points to the idea that what you feed the system, that carbon source,
right,
it's directly affecting how that biofloc community develops and survives. It's not just about giving them something to eat. It's about giving them the right thing to eat, you know? And these prebiotics, they're playing a bigger role than just being a simple food source.
So we're not just seeing faster growth, but we are seeing changes in the shrimp's composition.
Right.
And we're seeing changes in how much biofloc we're actually getting in the system. But I gotta say, the real meat of the study, and probably what's going to get a lot of people excited, is how they really dug into those microbial shifts, like how those prebiotics are actually changing the bacteria. The data, it's pretty clear they're having a big influence.
This is where it gets super valuable for anyone who's, you know, really into the microbial ecology of these aquaculture systems. I mean, they analyze those bacterial communities inside the biofloc particles.
Right.
And what they found was they got different profiles depending on which prebiotic they used. What was interesting is FOS, inulin, and even sucrose, they all kind of created similar bacterial communities in that biofloc.
And then your GOS and MOS, they kind of group together but separate from that first group. So, you know, for the folks out there who are thinking about really targeted approaches, it seems like there's some level of predictability, like you can anticipate how different prebiotics are going to shape that microbial landscape, at least in the biofloc itself.
And that's the mechanism, right? Like creating this selective pressure, that's how those prebiotics really exert their effects. But here's the thing.
Yeah. It
wasn't just limited to the biofloc water. They also saw changes in the bacterial communities, in the shrimp's gills, hepatopancreas, and intestines. And there were some really clear differences across the different prebiotic treatments.
And there were some like patterns there too, right? Like in the gills, the FOS, and the inulin groups, they had very similar bacterial communities. GOS had some overlap, but it was its own thing. And they saw similar trends in the gut and the hepatopancreas. This tells me those prebiotics aren't just doing their thing in the water.
Right.
They're actually influencing those microbes throughout the shrimp, you know, systemically.
So think about it this way, right? You're shifting the microbial community, and that could have all these benefits that go way beyond just growth. They actually noticed a trend toward increased bacterial diversity in the groups that got the prebiotics. And in aquaculture, you know this, a more diverse and balanced microbiota, that often means better resilience against pathogens, against, you know, environmental changes. Think about what that could mean for preventing disease, for keeping those shrimp healthy overall.
Now, one thing that anyone who's, you know, putting additives into their aquaculture system is thinking about is, what's this going to do to my water quality?
Right.
And I got to say, it was pretty reassuring, at least in this study, the general water quality parameters, you know, the dissolved oxygen, the salinity, the pH, they stayed pretty stable across all the treatments.
That's important, right? Because it suggests that, at least at these levels that they tested, these prebiotics aren't messing up those basic environmental conditions in those BFT systems.
Right.
You know, they're not causing huge swings that could throw everything off.
Right. But there was one exception that, you know, we got to highlight here. The inulin treatment, that one led to higher nitrate concentrations.
So if you're thinking about using inulin, that's a pretty important caveat.
Right.
You know, even in a generally stable system, specific prebiotics, they can have unique effects on how those nutrients are cycling, particularly with nitrogen processing. And folks really need to think about that in terms of their specific setup, their management practices.
Right.
You know, because high nitrates, that can cause problems down the line.
Absolutely. So if we kind of bring it all together for you, you know, the main takeaway here isn't that prebiotics are going to, you know, make those shrimp grow like crazy. What they really do is they change those microbial communities, both in the biofloc and, this is important, inside the shrimp themselves.
And yeah, even though we didn't see a huge jump in growth over those 26 days,
right,
the potential benefits of having a more balanced, you know, diverse set of microbes,
right,
that could be really significant for the long-term health and sustainability of your operation. It's exactly.
We're talking about things like better nutrient use, a stronger immune response, and better resistance to stress.
Yeah.
And all of that, that's crucial for efficient, reliable aquaculture production.
So this research, it's really adding to our understanding of how to, you know, tweak and refine those biofloc systems. And by understanding how to manipulate that microbial environment, we can get more targeted in how we improve shrimp health, how we improve the system's performance overall.
Right.
And that's how we move toward more sustainable practices.
So it's not about, that quick burst of growth.
Right.
It's about thinking long term.
It is.
It's about building a healthier microbial ecosystem
Exactly.
in the biofloc and in the shrimp.
Yes.
Focusing on stability, focusing on resilience.
I think that's a great way to summarize it.
Yeah.
I mean, it really highlights, all the complex connections in these biological systems.
Yeah.
And how valuable it is to keep researching these, these targeted interventions, these prebiotics, and how they can be used.
So given everything we've talked about, right, we've seen how these prebiotics can shape the microbes, both in the biofloc system and the shrimp themselves. What do you think are the most pressing areas where we need more research,
right,
to really nail down how to use prebiotics in commercial BFT systems to get those specific health outcomes, or even, enhance how the shrimp use nutrients?
Right.
Like, what are the big questions that are still out there for the folks who are actually working with these systems every day?
Well, one thing that jumps out at me immediately is we saw these short-term effects, right? But what happens over the long haul? I mean, if you're running a commercial operation, you need to know,
right,
do these benefits stick around?
Right.
Do they actually translate into, better survival rates, lower disease incidences, and ultimately, higher profitability over, multiple production cycles?
So really getting beyond that initial 26-day window.
Exactly. And then, this study focused on Penaeus Vannamei.
Yeah.
But what about other shrimp species?
Right.
I mean, could we see similar effects?
Yeah.
Do the prebiotics need to be tailored to the specific species? These are all questions that, need further investigation.
And then there's the whole, the economics of it all, right?
Absolutely.
At the end of the day, it's got to make sense for the producers.
Yeah, we need more research on the cost effectiveness of using these prebiotics, right? I mean, how do they compare to, other strategies for improving shrimp health and growth?
Yeah.
Like probiotics, or even, tweaking the feed formulations. We need data to help producers make informed decisions about what's going to give them the big return on their investment.
And even within the prebiotics themselves, we saw differences in how they affected the nitrate levels. So understanding those more subtle impacts on water quality, I think that's crucial.
Absolutely. I mean, those kinds of things, they can have long-term implications for the overall health of the system.
Right.
And for, how sustainable those operations are going to be in the long run.
Exactly. So to wrap it up, this study, it's a fantastic step towards understanding how we can really leverage those prebiotics in biofloc systems.
For sure.
But we need to keep digging deeper, to figure out how to make these systems even better, more efficient, more sustainable.
I completely agree.
So thanks for joining us on this deep dive, everyone. And, keep those questions coming. We'll see you next time.
If you enjoyed this episode, make sure to follow the Aquaculture Podcast Show on your favorite platform. And don't forget to follow us on LinkedIn, Instagram, and Facebook to stay updated on the latest episodes and industry insights. Thanks for tuning in, and we'll catch you next time.